Welcome to my channel. In this video, you're going to learn about simplifying radical expressions by applying the laws of radicals. So let's have a short review about the different laws of radicals. So if I have here the nth root of a raised to n, that is equal to a. That is if n is odd number. But if n is even number and a is a negative number, which means this is negative, you need to get the absolute value of a. So you notice here, the index and the exponent here is the same. So the answer is just simply the base here. Now, if I have the nth root of a times b, or ab, you can separate this as nth root of a times nth root of b. Which means if you are given a product here, you can change that or you can rewrite this product as a factors of two numbers. Now, if I have a quotient here, you can separate the numerator and the denominator. So the nth root of a divided by the nth root of b. And look at this one. We have double radicals here. Means that we need to get the mth root of the nth root of a. And simply by doing that, you can multiply the index here, m times the index n. M times n. Okay? So that would be the overall index, the product of these two. Now let's simplify the following radical expressions, and we're going to apply the laws of radicals. This is just the continuation or second part of my series of simplifying radical expressions. So please watch the first part. I'm gonna put the link below in the description. So here we have here the square root of 49x squared divided by 64y fourth. If this is a quotient, you can separate the numerator and the denominator. So that's one of the law of radical. So that is square root of 49x squared divided by square root of 64y to the fourth. And now, we can write this in exponential form. We know that 49 is 7 squared. And the index here is also 2. So applying now this law of exponent here, if they have the same index, here n, it means that the answer is a. If n is odd, and also if n is even and a is not a negative number. If a is negative, which means that you are going to get the absolute value of a. So now it means that is equal to 7. And also, we have the square root of x squared, that is x. So same index and exponent. The answer is simply x, the base. Here, 64, and 64 is 8 squared in exponential form. And y to the fourth, we want to make this as exponent 2. So we can rewrite that as y squared times y squared. Understood, the index again here is 2. So therefore, the same index now, that is 8. And again, the square root of y squared, that is y. The square root of another y squared is also y. So we have 2y, so that is y squared. Now for number 2, we have here the fifth root of 64 divided by 32x to the fifth power. So let's separate that first. We have the fifth root of 64 divided by the fifth root of 32x to the fifth power. Now, 64 in exponential form is equal to 2 to the 6th power. So we have the fifth root of 2 to the 6th power. And 32 in exponential form, that is equal to 2 to the 5th power. And x to the 5th power. So look at this one. In the numerator, we want to have at least 5 as exponents here. So we can simplify, and this is 2 to the 6th. And we can rewrite that as 2 to the 5th power times 2. Okay? This 2 to the 6th power, we can rewrite as 2 to the 5th power times 2 because in multiplying, we add the exponents. So 5 plus 1, that is 6. So we can simplify this or cancel the fifth root of 2 to the 5th power. Now, here in the denominator, we don't have problem anymore here because this is already 5 and this is 5, same as this. So that is equal to the fifth root of 2 to the fifth power is equal to 2, and the fifth root of x to the fifth power is equal to x. And now the numerator, so we can simplify this, and that is equal to 2, so we can write that outside the radical sign. And inside the radical sign is this number 2 because we cannot simplify that anymore. And that is equal to the fifth root here, divided by 2x. Now we can still simplify 2 and 2, and that is equal to 1. So therefore, that is the fifth root of 2 divided by x. That's the final answer. The fifth root of 2 divided by x. Next, now let's simplify this number 3. So you notice here, there's a double radicals here. So you can do it the usual way first. Let's do that one. That is the finding the square root of 400, and that is 20. Now, the answer is 20. You need to get the cube root of 20. But the cube root of 20 is this one, cube root of 20. There is no simplest form for this because there is no number raised to 3 where the answer is 20. Now, in this case, we can apply the laws of exponents or the law of exponents for this double radicals. It means understood that we have here 2 as index, and we can multiply this 2 times 3, and that is equal to 6. So therefore, the index now is 6. So that is now the sixth root of 128. Now, what is the sixth root of 128? So if you have problem in finding the sixth root of 128, what number raised to 6 that the answer is 128? Now, if you have hard time doing that, you can do the prime factorization. 128 actually is equal to 2 raised to 7. So I'm going to show you how. So let's have that 128, that is 64 times 2. And then, let's have 64 as 8 times 8, right? And then, we know that 8 is 2 times 2 times 2. Another 8 is 2 times 2 times 2. And then, we have another one here. So, we have 3, 6, and 1, that is 7. So, therefore, that is the sixth root of 2 raised to 7. Now, we can express 2 raised to 7 into the sixth root of 2 raised to 6 times 2 because we want to simplify. So in order for us to simplify, we can have this 6. Understood that 2 to the 6th power times 2 is equal to 2 to the 7th power. Understood there is 1 here. In multiplying, we add the exponent. So therefore, since we can simplify this one, we can bring that outside the radical sign. That is 2 times the sixth root of 2. So this number 2 remain inside the radical sign. So the final answer now is 2 times 6 root of 2. Thank you for watching and see you on the next one. Bye!